bell casting. So for this problem, actually it is similar to robbing house problem. So let me just go over with what is the rob house problem. So for rob house problem, we are having several houses in a line. If we rob the first house, it means we cannot rob the second house, but we can rob the third house. And then for the fourth house, we cannot rob it. But we cannot rob, maybe for the fifth house, if we didn't get the maximum value, maybe we're gonna rob the next house. Yeah. So this is the house robbing problem. It means we can rob some house, we can rob some of the house, we cannot rob it. So if they are the neighbors, so we can only rob one of them. And this is also similar, and we are having this power array, and for the power I, this is a value. So if the power I, let's just use the example of 3. If the power I, the value is 3, this means we cannot damage with 2, 1, 4, and 5. So this is the meaning. Yeah. So if the power I is 3, this means we cannot damage power I minus 2, power I minus 1. So power I minus 1 is going to be 2, power I minus 2 is going to be 1, and power I plus 1 is going to be 4, and power I plus 2 is going to be 5. Yeah, so this is the meaning. So we're going to turn this problem into a house robbing problem, and then the problem is going to become easier. So as we can see, there are duplicate powers. First of all, we're going to turn this power array into a counter. So we're going to turn it into a dictionary, and then we're going to just take out the case, because case is important for us. Now we're going to check the case from the right to the left. So for example, if we are going to let's just turn this problem into a house robbing problem. If we are going to rob this house, so what's going to happen is that we cannot rob a house which the value is 3. We cannot rob it. The value of 2, which we cannot rob it. If we are going to rob this 4, we cannot rob 3, but we can rob this 1, because 4 minus 1 is more than 2. Yeah, if it is more than 2, definitely we can rob it. So this means if we are going to rob this house, we can rob it, rob house 1 and to its left side. But if we are not going to rob this house, so what's going to be the maximum value? So the maximum value is going to be the house before it. So this means we are going to rob this house 3, and the conditions is just before it. So this is the idea. Now we're going to just to write a house robbing DFS to solve the problem. So first of all, we're going to prepare a counter. So it's going to be a counter of the power. Now we need to take the case. So I'm going to use a power. So it's going to be a sorted array with count.case, because I need to take out the case, and I'm going to sort it. And after sorting, I'm going to use this kind of a formula to solve the problem. Yeah. Now I can prepare a case, and I can prepare the DFS with I. Finally, I'm going to call the DFS. So I'm going to call it from the right to the left side. So it's going to be the length of the power minus 1. Yeah. So the condition is that if the I is go out of the range, this means definitely I cannot damage anything. So I'm going to return a 0. Now I'm going to take the value of the power. So I'm going to prepare x. It's going to be the power of I. So this is the value of current power. So I'm going to take it out, and I'm going to prepare index j. It's going to be I minus 1. So this means currently, if this is index I would to check the index I minus 1 if it meets the conditions or not. Yeah. So the condition is that I need to check this j. It must be more than or equal to 0. Otherwise, I cannot rob it. And also, we need to meet the formula. So the formula is going to be the x going to have a bigger power, because x going to be bigger because we sorted the array in increasing order. So x minus the value is going to be the power j. Yeah. So if x minus power j is less than or equal to 2, definitely we cannot rob it. So this means we need to decrease the j by 1 until this value x minus power j going to be more than 2. If it is more than 2, it is okay. So we can directly return the final result. So the final result is going to be the maximum of the two, because we want to return the maximum possible total damage that a magician can cast. So it's going to be the value before it. If we didn't rob it, so it's going to be I minus 1. But if we want to rob it, it's going to be this J, because only this J meets the condition, and we need to plus the value, because if we can rob it, so what's going to be the value? Let me check. Yeah, I think it is mentioned, but yeah, we can directly collect the value. For example, this is 1. We just need to collect those values. So the values, the current value, this is x. So we're gonna use x and times the counter with x, because we stored all those, because we wanted to know how many x are there stored. It is stored inside the counter. So we need to use x times the counter with x. So this gonna be the total damage for this value x. And this DFSJ will be all the values before it. So for example, the difference currently, if we are going to rob this 5, but we cannot rob 3 and 4, so we're gonna rob anything just before 3. So this is DFSJ. So J will be here. Anything just before this is 3. So this is DFSJ. Or we can choose another way. We are not going to rob this 5, but we are going to rob this 4. So we're gonna use the DFS I minus 1. It means we're gonna start from this value 4. So this is the basic pattern. Now let me just run it to have a check. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and it's passed all testing cases, and the time complexity is n log n. N is 10 to the power 5. And because we are giving this power length, it's going to be 10 to the power 5. So if all the values is unique, it means this power array gonna still be 10 to the power 5, but we are using the sorted method, and it's going to be n log n time. And the space complexity going to be n log n as well, because we prepared a counter. I think that's all for it. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. Thank you.